Another trigonometric substitution example, we have x cubed over 16 minus x squared dx under the square root 16 minus x squared. We want to make sure, first of all, we choose the correct substitution. We go back up to the top, and we notice that anything that has the form a squared minus x squared is going to have the substitution x equals a sine theta. And so, in this case, we know that a squared equals 16, which means that a is 4. And so the substitution that we should probably use for this is going to be 4 sines of theta for x. So x is going to be equal to 4 sine theta. We divide by 4 because we want to make our triangle. And we know that x over 4 is our sine theta, which means that that's going to be our opposite over hypotenuse. So the hypotenuse is 4, and the opposite is going to be x. And so on our right triangle, if we were to draw this, other way around. So we have this. So here's our theta, and our hypotenuse is 4. The opposite side is x, and then we can use the Pythagorean theorem again. But remember, it should work out to be what it is that we're trying to rationalize or eliminate the radical for. But remember, a squared plus b squared equals c squared, where c squared is the hypotenuse, so 4 squared, x squared plus b squared. This is going to render b squared equals 16 minus x squared, and then we can say that b is the square root of 16 minus x squared, which we already kind of predicted because that was going to be what we're trying to eliminate from this integral. So I'll get rid of all this stuff because we certainly know how to employ the Pythagorean theorem at this stage of our mathematical careers. And I'll just write it underneath just to save a little bit of room. And with trigonometric substitutions, you'll probably need all the room you can get. So this is the square root of 16 minus x squared. Now, before we can do any sort of substitutions, we have x, but we don't have dx. And so dx is going to be the derivative of 4 sine theta, which is going to be 4 cos theta d theta. All right, so learn that on one of the very first sort of derivatives that we ever found for Calc 1. All right, so now we're going to substitute. It's going to look a little ugly, okay, but they all do after that initial substitution. So we are going to have the integral of x cubed. So that's going to be 4 sine theta cubed divided by 16, or square root of 16 minus 4 sine theta squared. And then we have to substitute for dx, which is going to be a 4 cos theta d theta. All right, now at this stage, what we're going to do is we're just going to simplify the radical. All right, so let's leave everything else alone. And of course, we could try to expand the numerator a little bit. But if we try to evaluate this or simplify just this guy right here, that's going to turn into the square root of 16 minus 16 sine square of theta, just by squaring out what's underneath the radical. It's an ugly theta, but just go with it, which is going to turn into the square root, if we were to factor the 16 out, of 1 minus sine square theta. And we know 1 minus sine square is just the Pythagorean identity of cos square. So we get 16 cos square theta. And ultimately, this just becomes 4 cos of theta. All right, and that's actually going to be pretty helpful for us when we substitute. All right, so this whole thing right here is just going to become our 4 cos of theta. So next line, when we cube out that 4 sine cube, we're going to get 64 sine cube of theta. In the denominator, this whole thing becomes our 4 cos of theta. And then we still have the 4 cos theta d theta off to the side from the dx. Now, usually what's going to happen is something nice is going to cancel out. And it does this time. Okay, so we just get rid of that 4 cos of theta. We're left with sine cubed theta times 64. We can factor the 64 out, and we're left with sine cube of theta d theta. And now we get a problem that we looked at in the previous section where we had to evaluate these trigonometric integrals. Now, you might remember with your trigonometric integrals, if you have an odd sort of power, you don't want to use the power reducing formula. You want to split off a factor, in this case of sine. And that's what we're going to do. We're going to split off a factor, and we're going to write this as sine square theta times sine theta d theta. Now we're going to use the Pythagorean identity on the sine square. So 64 integrals of 1 minus cos square theta d theta. And we still have the sine theta in there. I just neglected to copy it. And what I'm going to do at this point is I'm going to split this up into two separate integrals. Or we could just use a u substitution right away, which I think I'm going to do with this one, although you could split it up into two separate integrals. So I'm going to go ahead and say this is going to be u is equal to our cos of theta. Because we'd like to be able to find something which derivative is going to give us exactly what we want. It's going to be really close. The derivative of cos theta is minus sine theta d theta, which is good news. Unfortunately, we don't want negative, but fortunately, we can divide both sides by -1. And we can get that negative du is going to be equal to sine theta d theta. So now substituting our integral, we now have 64 integrals of 1 minus u squared times negative du, right? Just by doing the substitution. So sine theta d theta is negative du, and then obviously this just becomes u squared. We can factor the negative out, and we get negative 64 integrals of 1 minus u squared du. And now we have a really basic integral to evaluate. So this is going to be negative 64 times the quantity of u minus 1/3 u cubed plus c. Remember, u was cosine of theta. All right, so that's going to be negative 64 times the quantity of cosine theta minus 1/3 cos cubed theta plus c. All right. Now, the last thing we have to do with this is get it out of theta and back into x. We know that the cosine function is going to be the adjacent over the hypotenuse. This is where we have to go back and use that triangle one last time. All right. So we're going to go back up, and we know the adjacent is square root 16 minus x squared. Hypotenuse is 4. So let's just go ahead and plug those back in, right? And so we get negative 64. Remember, adjacent over hypotenuse. So square root 16 minus x squared over 4. All right, so that's going to be our adjacent over hypotenuse minus 1/3. And we have to be careful with this because it's going to be cubed. The square root of 16 minus x squared over 4 cubed plus c. All right, so this whole cosine is going to be cubed. All right, now we could certainly simplify this just a little bit. Okay, and here's how we might try to simplify it. We can just have our negative 64 on the outside. All right, we can't do anything yet until we distribute that 64 minus 1/3. Now we know that 4 cubed is 64. And I'm just going to rewrite this animal as 16 minus x squared cubed plus c. All right, so one answer that we can get when we distribute that 64 through is going to be negative 16 roots of 16 minus x squared. And then that's going to cancel with this 4. And then the 64 and this 64 is going to cancel out. We're going to get a plus there. So we're going to end up with 1/3 square root 16 minus x squared cubed plus c. And that's certainly one answer we can get. One other way to simplify this, and I'm not suggesting that you have to do this, but if you're using a computer algebra system, often what they'll do is they'll factor out one of these square roots. Okay, so they might factor out a square root of 16 minus x squared, and that's going to leave you with negative 16 plus 1/3 square root 16 minus x squared plus c. So we factored out one of these square roots, right? The square root and the square are going to simplify, right, like that. And we could end up with the square root of 16 minus x squared times negative 16 plus 16/3 minus x squared over 3 plus c. And then finally, if we were to add these together, this would turn into a negative 48/3. So this is going to ultimately just simplify into 32/3. So another way to write this would be square root of 16 minus x squared times negative 32/3, and I guess minus x squared plus c. And I guess technically, if we really wanted to factor out a negative 1/3 from this, probably the most factored answer we get, negative 1/3 square root 16 minus x squared. And we would have our x squared plus 32 plus c. All right. However, I'd recommend just leaving it in something like this form, where you simplify it and you don't factor it down necessarily. Certainly benefits to having this factored form. You can clearly see that the domain of the function would be from -4 to +4. Anything past that would be it would be outside the domain. So, all right. So again, another, and I want to say this in quotes, fairly easy sort of trigonometric substitution problem. All right. We are going to look at a few more tricky ones as we go along. All right. So make sure that you understand the process before you go on and try some of the harder ones.